Suspended in the silence of space, a golden mirror stares into the past. The James Webb Space Telescope, orbiting 1.5 million kilometers from Earth, isn't just another observatory. It's a time machine, a cosmic archaeologist, a heat-seeking eye that peels back the darkness to reveal the birth of stars, the birth of galaxies, even the birth of the universe itself. Launched in December 2021, JWST has already delivered images and data that challenge everything we thought we knew. Galaxies too old, planets too strange, structures too advanced for their time. It was designed to look deeper, farther, and older than any telescope before it. And now it's beginning to rewrite the origin story of the universe. Welcome to Skyward Space Quest. Today we explore the telescope that sees time and the discoveries that are shaking the cosmos. To understand why Webb is so powerful, let's compare it to what came before. The Hubble Space Telescope, launched in 1990, changed astronomy forever. It captured stunning images of nebulae, star clusters, and distant galaxies in visible and ultraviolet light. But Hubble had limits. It couldn't see what was hidden behind cosmic dust. It couldn't detect the faint, stretched-out light from the earliest moments after the Big Bang. For that, we needed a new kind of eye. One that sees in infrared. Infrared light is heat. It can penetrate dust clouds and trace ancient structures, and because the universe is expanding, light from the earliest galaxies is redshifted, stretched into the infrared. Webb was built to find that ancient glow. Its mirror is 6.5 meters wide, over 2.5 times bigger than Hubble's. Its 5-layer sunshield blocks heat from the sun, keeping the telescope colder than minus 230 degrees Celsius. And it sits far from Earth, at the second Lagrange point where the Sun and Earth's gravity balance. The result? The most sensitive, precise, and powerful space telescope humanity has ever built. Creating Webb was a monumental engineering challenge. Over 2 decades, scientists and engineers from 14 countries built a machine of folded mirrors, origami sunshields, and cutting-edge cryogenic instruments. More than 100 technologies had to be invented from scratch. It had over 300 single points of failure. Every component had to work perfectly after launch. The sunshield alone is the size of a tennis court. It had to unfurl in space, layer by layer, to protect Webb's instruments from even the faintest heat. Its segmented mirror, made of beryllium and coated in gold, had to fold up inside a rocket fairing, then deploy with millimeter precision in microgravity. And once in space, it had to travel 1.5 million kilometers with no chance of repair. In early 2022, against all odds, Webb fully deployed. The golden mirror opened like a cosmic flower, and humanity's new eye on the universe began to see. James E. Webb was not a scientist. He was a NASA administrator. During the 1960s, as NASA focused on the Apollo moon missions, Webb fought to keep space science alive. He believed exploration without understanding was incomplete. Today, the telescope named after him honors that vision, pushing not just where we explore, but how deeply we understand. In July 2022, NASA released the first full-color image from Webb the SMACS 0723 Deep Field. In a patch of sky smaller than a grain of sand held at arm's length, Webb revealed thousands of galaxies, some over 13 billion years old. Many of these galaxies were warped into arcs by gravitational lensing, where massive foreground clusters bend and magnify the light of background galaxies. And behind them lurked impossibilities. Galaxies that were too massive, too well-structured, and honestly, too luminous for their apparent age in the universe. One galaxy appeared to be just 300 million years old, but already had a mature spiral shape. That should be impossible. Our models say galaxies take billions of years to form spirals. Webb was challenging our most fundamental timelines, and hinting that maybe something big was missing from the standard model of cosmology. Next came the Sears Survey, Cosmic Evolution Early Release Science. It uncovered even stranger finds: compact galaxies forming stars at incredible rates, giant clumps of matter swirling into disks, and galaxies merging, colliding, shaping one another. One candidate, Sears 93316, appeared to exist just 250 million years after the Big Bang, and it was already massive. Another galaxy, Glass Z13, could date to just 300 million years after the beginning of time. So, what does this mean? Either our understanding of galaxy formation is flawed, or the early universe was far more efficient, and honestly more chaotic than we thought. Webb may have uncovered a hidden chapter in the cosmic origin story. After the Big Bang, the universe was hot, dense, and bright, but soon it cooled and went dark. For hundreds of millions of years there were no stars, only hydrogen gas. This was the cosmic dark ages. Then the first stars ignited, the universe lit up, and galaxies began to form. Webb's primary mission is to find the light from those first stars, the moment the cosmos became visible. JWST isn't just looking back in time, it's also looking sideways at distant exoplanets. By analyzing the spectrum of starlight that passes through a planet's atmosphere during a transit, Webb can detect molecules, even on worlds hundreds of light-years away. So far it's found water vapor on WSP-96b, carbon dioxide on WSP-39b, and sodium-sulfur dioxide, and even clouds made of silicates. These are hot Jupiters, gas giants orbiting close to their stars, but they're just the beginning. Webb is now targeting rocky Earth-sized planets in the habitable zones of stars like TRAPPIST-1 and LHS 475. It's searching for biosignatures, gases like oxygen, methane, and ozone, that could hint at life. For the first time in history, we might, detect the chemical fingerprint of a living world without ever leaving our own. But one of Webb's most visually stunning capabilities is, honestly, its ability to pierce cosmic dust, those dark clouds where stars are born. In the Carina Nebula, Webb revealed jets of gas from newborn stars. In the Tarantula Nebula, it traced these vast filaments of star formation, and in the Pillars of Creation, it exposed infant stars still forming in the womb of dust. But Webb can also witness the death of stars. In the Southern Ring Nebula, it captured a dying star's final breath. Layers of gas ejected into space, forming a glowing shell from birth to death, and every dusty moment between, Webb is watching the life cycle of stars unfold in, exquisite detail. So, infrared light has longer wavelengths than visible light. It can pass through dust and reveal cooler objects like forming stars, distant galaxies, brown dwarfs, and even planets. But to detect it clearly, a telescope really has to be kept extremely cold. That's why Webb's instruments are chilled close to absolute zero. In the dark, cold silence of space, heat is light. Webb is just beginning its 10-year mission, possibly extendable to 20. Coming soon, ultra-deep field surveys reaching back to 100 million years after the Big Bang, detailed maps of early galaxy clusters, climate studies of rocky exoplanets, and perhaps even the detection of alien life. And beyond that, NASA is already planning successors like the Nancy Grace Roman Telescope, the conceptual Louvois and Haybex missions, and telescopes that may one day take direct images of Earth-like planets around Sun-like stars. We're entering a golden age of astronomy, and Webb is the gateway. In just its first year, the James Webb Space Telescope has shown us a universe more ancient, more complex, and honestly more alive than we ever imagined. It has found galaxies that shouldn't exist, planets with impossible skies, and starlight that began its journey before Earth even formed. But more than anything, Webb has reminded us the more we see, the more we don't know. This golden mirror isn't just reflecting light, it's reflecting our deepest questions. Who are we? Where did we come from? And are we alone? This is Skyward Space Quest. Don't forget to like, subscribe, and join us next time as we continue our journey through the stars.